Okay, so in this video clip, we're going to again take a look at the Python code for Black-Scholes Greeks. And instead of estimating using the Jupyter Notebook that we had done before, Jupyter Notebook, we are going to put it into OnlineGBD, which is kind of a practical way and fast if we don't have access to Jupyter Notebook. So let's just copy that snippet of code. Now remember, the code is coming from Davis Edwards, and I've left a link here, and he's based this Greek estimation on the generalized Black-Scholes model as set up by Espen Hogan, his textbook. So okay, let's just copy. Then we will go into OnlineGBD, GBD, which is an online compiler. Normally I use it for C++, but here I'm going to use it for Python. And we can paste in our output, paste. Okay, and again, we can run that. Now again, remember what we have here is we calculate our D1 and D2 usual fashion for Black-Scholes. We have a dividend included here in B. B is the cost of carry. B is equivalent to R negative Q, the risk-free rate minus dividend yield. Then we have delta gamma theta vega and rho for the call, and likewise delta gamma vega theta and rho for the put. If we run this as currently is, and we estimate Merton and specify, now Merton is the function that includes the dividend yield. If we run Merton here, you can see nothing comes out. We really have to go one step further. The code is executed. I think everything is fine, but to obtain output here, right, we need to set Merton equal to C. So C equal to, or we could say call equal to, but let's go with C for the moment, and then print C. So let's run that, and this time we should get an output where we have all the value, the time value of the option 1045, the delta, the gamma, the theta, the vega, and the rho in our output. Okay, so we are able to incorporate in a dividend yield. We use this Merton specification. Again, you can trace back Merton here, where we denote B is equal to R negative Q, and then we reposition the B in the formula before. We would have just had we would have obtained that value. Okay, so let's just, I'm going to stop it there. We can see the output, and it seems to work quite well. That's one way of estimating in the OnlineGBD using the Merton, using the generalized Black-Scholes framework, and using the code obtained from Davis Edwards. And I've left a link in the Vinegar Hill portal for that.